make the account model private, you can keep the transactions confidential. That is, the data inside the transactions, you can hash them and do all of that. But the address that is sending those transactions and receiving those transactions, they cannot be private, right? They cannot be encrypted, because how would you verify anything on chain? So the record model improves privacy by using these program IDs instead of account addresses to organize data. So you have programs which are essentially your smart contracts. They maintain their own internal state. So this also means that there's no need to access and update the complete state of the network for each and every transaction, which also makes Aleo's design much more efficient. So let's look at Alice, who wants to send Bob some amount of tokens, right? So she has a record which has 50 token balance, but she only wants to pay Bob 30 tokens, let's say. So she creates a transition, and the transition will burn this record of Alice's, which has 50 tokens, create a new record for whose owner, every record has to have an owner, whose owner is Bob with 30 tokens, and another record whose owner is Alice with 20 tokens. And it basically, like, I'm putting the mapping as returned, but it stays within the program. So there are two new records created and one record that is burnt. Let's say Alice wants to give another 5 tokens to Bob. She would again give this, that's not represented in this diagram, but she would give this record of 20 tokens back and create another transition function, which would give 5 tokens, create a new record of 5 tokens to Bob, and return the 15 tokens back to Alice. So at the end, Bob would have one 30 token record, which was created initially, one 5 token record that was created the second time, and Alice would be left with the 15 token record. And her initial 50 token record and the second 20 token record are burnt in these 2 transactions. So this is how this would be executed on Aleo, right? So these records are they don't appear directly in Bob's or Alice's wallet. The clustering point is the token program with which they interact, and the record themselves have an owner, which tells them whether the record can be used by Alice or Bob, right? Okay, so so now that we have like a high-level understanding of how transitions work, how record model is in Aleo, we'll talk a little bit more about the Leo programming language, which is the Solidity equivalent for Aleo. Right. Okay. So this is a very simple token. Please let me know if you can't read it, if the font size is too small, and I can show it to you on VS Code or something. So this is a simple token. Consider it like your ERC20, like, or SPL token for Solana users for Aleo. So okay, so since I said that every record is associated with a program, every program has to have a unique name. So you can't deploy more than one program with the same name. That is also another important, interesting thing to note. So here I have a token. I've named it tutorial. So here there is a record called token, right? And every token must have a owner, and this is a very simple token. So in UTXO model, every UTXO can only have a balance, but in Aleo, every record can be like as complex or as simple as you like. So here you have a balance field. This is a very simple record, right? And how would you mint that token? You simply take an amount that you want to mint, and it will return a token record. And the record is just basically assigning the caller as the owner and amount. So it's just, so we're not putting any restrictions on who can mint over here. So it's just a simple program. Oh, oops, sorry. Yeah. So now, and the transfer would be just as simple. So you would have to take an input record and the receiver's address and the amount that you want to transfer. And then you need to burn that input record and create 2 separate records, one to return back to the owner on the balance, and one to give the receiver his new token balance, right? That's exactly what is happening here. You have a sender balance. which is basically the input balance minus the transfer amount. So you're creating two new records, for one for the recipient and one for the sender. The sender will get the balance back, and the receiver will get the transfer amount. Right? So it's as simple as that. Okay. So yeah, let's move on. Okay. So now Leo wallet is a self-custody wallet on Aleo, right? But Leo is not just like any other wallet that you would have seen on public chains. Let's compare it to, let's say, MetaMask, right? It's not a trivial thing to build a wallet on a private chain. So why is that? Any other wallet on a public chain is basically a wrapper over some APIs that the chain or the node provider gives. So along with that, they also have like a key store mechanism and a signing mechanism. So, but Leo wallets cannot simply be these three things alone. Okay, Leo wallet has to be more because um, private chains have encrypted states. Like you can't just get the balance from the chain. When you get it, it'll be in an encrypted state. So Leo wallet has to first deal with this encrypted state of the chain. Right? Other wallets can just call the public chain, call an RPC API to read or write from the chain. But when you do this on Aleo, it doesn't know the exact state. It only comes as an encrypted state. So the wallet has to do the state management also, which is a lot harder. And even explore, like even dApps or explorers, you can't just go to an explorer and search for your address and get all the information, right? Even explorers have to connect with the wallet and get the user's permissions to decrypt the user data on chain with the user's key. So the user will have not only a private key but also a view key, which basically allows any dApp to decrypt the asset values for the user, right? And on top of this, when you want to send the transactions, you have to be able to. So in Aleo, it's a ZK chain. So when you do perform write transactions on this chain, you're basically creating a proof, and that proof is what you're sending on chain. So the proof is generated on chain. So when you are using the Leo wallet should be able to generate these proofs for you before publishing it on chain. And this is a big deal because, like, if you look at ZK rollups, right? ZK rollups have this dedicated hardware. They have like hundreds of GBs of RAM that are dedicated to creating these proofs for you, right? But Leo has to do this on like a user's mobile phone or on a browser. So it's a very compute heavy thing that Leo wallet has to do. So which is what makes Leo, like any wallet on a private chain like Leo, much difficult, much more different than a public chain wallet. Okay, so a quick thing, you can maybe take a photo of this, or I can share a link, or you can just go to this www.leo.app to download the Leo wallet. So maybe we can do this a little bit later. And a quick some numbers on Leo wallet. So Leo wallet currently has about 250,000 weekly active users, and Aleo, it's I think the most popular wallet on Aleo. Aleo is in testnet right now, soon launching mainnet. So this is currently a testnet wallet, and it is fully self-custody, right? And it also has a faucet feature where you can directly ask for funds from Aleo. So I already have the browser version of the Aleo wallet installed here, and I've done a couple of transactions. So you can see the faucet button right here, right? So I'll show you a quick demo of how this Leo wallet works. So if you want to get, I mean, you can, it's very simple. Like it's how you would install MetaMask. Or if you're familiar with any Web3 wallet, it's as simple as installing those wallets. So once you have installed and pinned it to your browser, it would look something like this. You can just ask for faucet. So there are a couple of ways to get Aleo credit. So credit is how you call the native token of Aleo. And how you have like Satoshis to Bitcoin or way to ETH. So we call micro credits for a credit, Aleo credit. Again, 10 to the 6 microcredits is equal to 1 Aleo credit. So all you have to do is click this faucet button, join this Discord. You have to verify your account on the Discord server, and then you can go to the faucet channel. Right? Yeah, but you can go to the faucet channel and you can copy your address over here, copy this Aleo address, and then paste it on the channel. Let me see if I can just show it to you here. Yeah, it looks something like this. Okay. So so you just have to request from faucet, and then you paste your address, and yeah, and then you submit. So it's as simple as that. Right? But yeah, you can only get some faucet funds every 2 hours or so. So maybe the link to the Discord also we can put on the chat. Let me just do that quickly. Right, you can maybe join the Discord meanwhile. Okay, moving on. Right, and there is a CLI tool available, but if you want to deploy Aleo programs, Leo also has a feature to directly deploy programs. So Leo has something called the Demo Leo app. So if you can go here, I'm going to put this link also. Yeah. So in this, you can directly deploy programs. So if I go to a deploy screen here, you'll have to put Aleo instructions. Aleo instructions are basically the Leo code. When you compile it, it gives you a set of Aleo instructions. And these are what is used to produce the circuits. You can do this Aleo scan is the block explorer that Aleo uses. Right, and so you can also, it also has this cool estimate fee feature, but I usually it takes me about like 10 credits to deploy a program. So let me try deploying the token program. Okay, let's see. Okay, so this is the token program that we saw earlier. Right here, I've already compiled it. So all this documentation is available again on. So if you see Aleo Dev docs, yeah. So there's pretty extensive, really good documentation on how everything, like on the concepts of Aleo. So I would highly recommend you go see this. Now coming back to our deployments. Okay, so this is the main Leo code, which I just showed you. When you compile it, it gives you Aleo instructions. So as you see, it's the same thing, but in a different format. So you have each function and the record here. Okay, so I'm just going to copy this Aleo instructions, and if I go to this deploy tool that Leo Wallet has, just pasting these instructions. And I told you every program has to be different, so you can just put like build her workshop. Okay, and this fee, I'm gonna say 10 credits. Okay, so 1, 2, 3, 10 credits, which is 10 to 10 to the 7 microcredits. So 1, 2, 3, 4, 5, 6, 7. Right. So I've already connected to my Leo wallet over here. So when I say submit, it automatically asks, and here you can see the conversion. Sure. Syntax of the code is actually in the example, but I can just give you the instructions here on the chat. So, and I'll also give you the code of the. Right. Okay. Hmm. So I can confirm or reject this. You can check how much fee. So the fee is from the microcredits. It's converted into Aleo credit. So I know that the number I've put is correct. So I'm going to confirm. So let's see what happens. So here, yeah, so it's deploying this, the program that I have just created. So what is really happening in the backend? So Leo has something Leo Wallet has a really cool feature called delegated deployment. So what is delegated deployment? So basically, if somebody writes a program, these programs are like smart contracts on Ethereum, and it's compiled into Aleo instructions. And we are basically deploying these Aleo instructions, right? Upon deployment, everything is getting converted based on the instructions. You're creating these circuits, and all of these each function needs its own proving and verifying key, and this is based on Aleo's universal setup, and it's a very slow process, right? So since Leo has to do this on like restricted devices like mobile phone, they have a they have a server that can trustlessly deploy these circuits for you, create and do it much faster. So this is what is delegated deployment. Okay, so you can see, so yeah, you can see the different stages on okay, so this is the deployment transaction, and you can see that the program has been deployed. One thing is, okay, even at deployment is the only part where the address of the person who's deploying is also visible. So if you want that to be private, then create a burner wallet, transfer some Aleo credits for fee to that burner wallet, and then deploy from that wallet, because the address of the deployer is going to be on chain. Okay, so yeah, so this is how it looks. So this is the address that who deployed and the fee that was paid. So it's going to be public. So you can, if you want that to be private, then create a burner wallet and do it. So why is what exactly happens in program deployment? So let's look at here. So when this is a deployment transaction, very similar to Ethereum, where you're deploying a smart contract. So when you deploy it, there is an Aleo, it goes basically invokes an Aleo program. There's a list of validators. So there's no like proof. So the program code is public. So it just directly goes into the registry. So that's when everyone can verify the logic of a program. And validators can just look at the program. It's basically a namespace, and every program has a unique name. So, and if when for private transactions, the records are associated with the program ID, right? So we need to know which program that they belong to. So that's why they have to be unique. Validators will basically add them to their program registry, and it's all set. So, and this program is ready to be invoked, right? And that's the deployment transaction. Now, when you want, how can you invoke these programs? So let's say there is there's some request to invoke the program. Now, there's some changes, like some records are burned, some new records may be created, and there can be some public states also. So what happens is all of this execution is done offline in an entity called the prover. Now the prover will generate the proof for this whole transaction, and then they send basically they send the proof to chain for the validators to verify. So you have the developers who write dApps, they can execute transactions, and the provers will actually execute those transactions and create the proof. The proof is sent on chain, and the proof is validated by the validators, and the record of this whole thing is sent as a transaction that can be viewed on the Explorer. But only the people who have the key to decrypt these transaction details, whatever is public, will be able to view. Otherwise, the instance of the transaction is there on the Explorer, but you can't really see the actual values. So this is how it looks on Aleo. Most of the time, the prover is not a third party. So if you're deploying through, if you're invoking something through the Leo wallet has this the prover element attached. Or if you're writing your own script, you can also run your own prover locally, right? Yeah. Okay. So let's look at NFT dApp. Okay, so Leo wallet, that is Demox Lab, has created a very cool, fully private NFT minting creation dApp for you that you can code and learn from. So this is like an ideal template that has all the things that you would need to know um, to build your own dApp. So things like how to fetch data from the chain, how to write data to the chain, how to fetch from the wallet, or like how to request for transaction data, and all of that. So you can study from this repo and learn how to do it. And the utility or the use case this dApp is built for is to create a collection, mint your own NFTs. So it can be compared to if you know Solana, it can be compared to Candy Machine. Candy Machine is a tool that helps you create NFTs and collections on Solana. So this is a equivalent on Aleo, but it is built as a private dApp. So you can find the repo over here. Again, I can give you the link. 1 second. Just let me know if this works. Yeah, so this is the link to the repo, and you clone it in your local. There are a couple of changes that you have to do on this repo. So let me just quickly walk you through them. Okay, so this is the repo. I'm already running it here, but yeah, so this is how it would look. So the Aleo, the programs are there in here, src main.leo. So when you execute it, you'll also get the instructions. So this is the Leo contract for this whole application, the NFT minting, transfer, whatever, all the logic is there in this program. You will have to go to the env file here and change these two things. So the address would be the public address, your wallet address of the Leo wallet that you just created. And the program would be, you can change the name of your program, put something unique, right? The program name has to be unique. So you change these two aspects and you're ready to go. Right. Yep. So the repo also has a README. Just go through that also. I think you'll just have to directly run yarn dev, if I'm not wrong. Yeah, just follow the instructions in the README. But yeah, I think you just have to run yarn dev, and something like this should open. Let me just see if I'm already running it. Yeah, okay. So you should be able to, when you do yarn dev, so I'm running this in my local host. Yeah, the application should load directly, right? So this is like the mint and the user facing page. Let me just connect my wallet. Yeah. Okay, but this website, this DApp has two aspects to it. One is the user view. So if you're building your own DApp, you can like see how things are coded on this page. But it also has an admin view. So I'm just going to put slash admin over here. And if you, this pretty much looks like the demo app page that we just saw, but this is for NFTs. And Leo Demox Lab has like done a really good job over here. It just makes everything easier. So again, you can connect your wallet, and anything that you would need to create and manage a NFT is given here in a nice UI. So you can also go and see how these pages are coded to understand how they work in the back end. So you can directly deploy the NFT program. If you see that, it automatically takes the program name that I gave, and the address that I'm calling from, and the data, the instructions, the Aleo instructions is also taken from the code base. And yeah, it has a fixed a fee here. So you can also just go ahead and submit this and try to deploy your own NFT program. Okay, but if you want to do anything else with this, second, yeah, if you want to do anything else with this NFT collection, you can also do that. You can initialize the collection. You can specify how many items you want the collection, you want the symbol of the collection, the URL of the images of this collection, and you can submit that as a transaction. If you want to whitelist addresses, you can do that. You can also add NFTs to, you can add it one by one, or you can also do bulk uploads. So again, I urge you guys to see how all of these are coded and how they work. And there are a bunch of settings that they've already thought of. Minting statuses, like you can turn off whitelisting. Yeah, right. Cool. So yeah, please do check it out. Okay, let's come back. Okay, so right. So let's look at some deeper interesting aspects of how NFTs can be created on Aleo, given that it is a private blockchain. So, yeah, okay. Can you see this? Not sure if the font size is too small. Please let me know. Yeah, yes, you will need to change in the Git. You don't have to change the code. You just have to change the env file. You will have to update the address to your Aleo address, and the program name, you can put your own NFT program name. Keep it unique because every program has to be unique on Aleo. Okay. Right. So how do you even create NFTs? Let's talk about that. So in Leo, there are both public and private representation of assets, right? The private representations are the records, which can only be used once, and they get burnt in every transaction. And that you can also have public representation. So whatever you can do in Solidity, you can also do in Aleo with public representations. So, but based on your applications, you might want the NFT to be public or private, or even both. You can't really, depends on your application. So let's say, I mean, if your NFT is public, it makes things like selling the NFT, like displaying it, cataloging it somewhere, or displaying it on a marketplace, much easier. But like you might want to, let's say, keep the ownership private. Like, I don't want to reveal that I'm the owner of this NFT, but I want to, maybe show off the NFT somewhere, or like gain some kind of, maybe like I have it's an NFT, like an ID card as an NFT, or like an NFT for token gating, right? So BYAC, that those NFTs actually like gives you entry into parties and all. So for gated entry, you might want to even though your ownership is private, you want to maybe prove that you own the NFT to get entry into wherever you want to go, right? But there should be some aspects that are definitely public, otherwise the whole thing loses its meaning. So let's say on a collection level, how many items are there in the collection? That has to be public information. And let's say how many NFTs are owned or how many are not yet minted. That also has to be private, public information. And you should be able to verify that, people should be able to verify that the NFT is indeed unique. Thing like you need to be able to verify that the minted NFT is unique, and also it has one single owner. Like many people don't own the same NFT. Like things like that should be made public. But there are aspects like ownership that you want private, and maybe other details like the name or the symbol of the NFT. Like all of these should be public. So there is lot of things that you have to think about. So it's very difficult to have a completely private asset when you have public data associated with it. So in these cases, we try to make it as anonymous as it can be fully private, but it can be as anonymous as possible. Okay. Right. So let's see how we can do that. I think this is this font is definitely too small. I think let's look at it in the code. Okay. So let's look at how mint works. Okay, so in the case of mint, again, as I said, if it is a single party transaction, that is only one user is involved, that he's just changing something on the chain, you can make it a completely private thing. There's no problem. But when there are multiple parties involved and you want the transaction to be atomic, like you shouldn't have to depend if the other party is on chain or available. It's very difficult to make it fully private. So we try to make it as anonymous as possible. So in the case of mint, if you mint publicly, then people will know that the NFT is minted to your address. So how do you prevent that? You want to make the NFT public, but you want to keep the ownership private. So how this demo app has solved that problem is they've tried to do it in this interesting way. Let me increase the font size. Maybe you can see this here. Right? Okay. Okay, cool. So how they have done it is they create two records for a mint. One is basically the NFT is minted to some kind of random number, not an owner. So, and the owner has a proof that he owns the number. Let's say like it's minted to a hash number, and owner knows the actual number of this hash. So the record is created, the mint record is created for a random number, and the owner can claim it at a later point of time by proving that he owns that number. So this is how we kind of decouple the ownership from the NFT. So yeah, the owner always stays private in this case, but the NFT and the random number is their public, which is okay. Okay, and how would you transfer this NFT? Yeah, transferring is pretty simple. It's let's go to the transfer. So in transfer, all you have to do is that you have the NFT record, you burn that record, create a new record with a new owner. Just the ownership changes. So this is how you can easily even transfer this NFT. Right? We just okay. Coming back, this is how you would transfer this NFT. Okay, let's talk about some other really nice use cases that you can build by getting inspiration from this repo. So let's talk about ZKID, this gated proving your identity on a dApp, maybe. Right? In Ethereum, this is pretty simple. All you have to do is like sign a message via your Ethereum wallet, MetaMask maybe, and then immediately basically you're proving that you own this address, right? All you have to do is sign a message and the DApp will allow you entry saying that you're the owner of this address. But let's say you need to prove, and in Ethereum, let's say for token gated, if you have to prove that you own an NFT, you just have to sign a message and the DApp can directly check the NFT contract if one of the owners of this NFT is this address that you just signed. So it's as simple as that. The DApp has direct access and you can, like, it can do everything. But how do you do this in a private blockchain like Aleo, right? One thing is the DApp can ask the wallet if the user has a particular NFT, because the DApp can't see it itself, right? Everything is encrypted on chain, and the DApp doesn't know. But the wallet has access to see the asset. But how can the DApp trust the wallet that it's not lying or it's just not faking that the user actually owns this NFT? So again, we use the power of Leo language here, create another ZK proof basically. So you can have something, you can embed this authorization, like this signing in feature in as part of your Leo program, like an authorize function. So all the DApp has to do is invoke that authorize function through the wallet. Okay, so the wallet will pass the NFT record, and then authorize function, you can do whatever check you want. Maybe you can say that the public number that you're minting the NFT to is the actual number within the NFT. You can do whatever check you want. And upon when if that check is correct, then you basically pass it to a finalized function. Why do you have to do that? Because as I said, everything has, once a record is used in a transaction, it has to be burnt. Like you create a new record and then you assign it, because it can only be used only once. But for authorize, you can't keep creating this NFT, right? It's going to take and it's just not practical. So you can pass it to this something called a finalize function, which is a feature in the Leo language. You can go read about it. So this finalize function, you put a inequality that ensures that it always fails. So the check has passed, but it always fails, right? So, and the whole thing doesn't even have to go on chain and reach consensus and all that, which is going to take a lot of time. So this is a very simple way we can execute something like a DApp sign in, which is similar to how like login works in other dApps for Ethereum. And this ensures that it gives you a Web2 like experience, because nothing is happening on chain, and you have a ZK proof that ensures that the wallet cannot lie. So this is a very fast sign-in mechanism that you can use. Yeah, that's pretty much all I wanted to say. There's an example of how authorize is done also in this. Yeah, there is an authorize function here, right? So please do read, go through the repo, and yep, that's it from me. Happy to answer questions.
Thank you, Ovia. That was wonderful. Appreciate the details and the clarity. My Wi-Fi was a bit wonky, so in the first little bit, it didn't record. So are you able to share the presentation slides so that'll be more helpful?
Yeah.
Great. Wonderful. Thanks, everybody. I'm going to drop the Telegram link in the chat, so office hours will continue there. And again, a reminder that you'll be receiving all the recorded workshops by end of day today, and you'll have 7 days to complete the learning objectives. Thank you.
I think there are a couple of questions on chat. I'll just take a few minutes to address them, if that's okay.
That's totally fine. Yeah, go for it.
Yeah. So first thing is first, I'm going to give you the copy of the slides. Okay. Okay, so let me. Okay. Yeah, please let me know if you can access the slides. Okay, and yeah, so I just showed you a very easy way you can deploy Leo programs. I like it's we don't have a there is a Leo Pro playground if I'm not wrong, but there's not something like Remix for Aleo yet. You can deploy programs in two ways via the either by terminal by the client tool, or you can also use the Aleo demo app for deployments, right? So this is, you simply go to demo.leo.app by Demox Labs, and then you have a deploy here. You just have to compile the code and paste the Aleo instructions and set your fee, and you can submit it directly. So again, use a burner wallet, and this is how you can deploy any Aleo program, right? Awesome. Any other questions? Cool. Awesome. Thank you, guys. Thanks, Roxana.